Hello guys, welcome back. This is Krishna and welcome to AI Martians. So today I'm going to talk about optimizers. Okay. So far I talked about loss and their implementation. Okay. And now after calculating loss of a model, we calculate optimizing. Now what is optimizing? Okay. So before that I have to tell you two things. First one is derivative and second one is partial derivative. Okay, so let's go to Google Colab Sheet. Of course, I'm not going to write any kind of code for now because optimizer work on derivative and partial derivative. Basically, it work on partial derivative, but you guys have to understand like what is derivative, what is partial derivative. Okay, that's why I just wanna give you the introduction regarding derivative and partial derivative. So let's go to Google Colab Sheet because I have to make some notes there. So guys, this is the concept which we have to start now. Okay, so this is optimizer, our seventh number concept. I'm simply going to copy this and paste it in a new shell at the very end. So let me scroll it down. Yeah, it's already mentioned there. So optimizers. I'm talking in the section about derivative and partial derivative. Now, what is derivative? So first, I would like to tell you something. Let's say I'm drawing a picture. Let's say when we train a model, when we train a model, okay, let's say I'm going to train a model. So I need a data set first I require. Then I have to pass it to scale. Okay. Third, break data into training and testing. Okay. After that, create neural network and we compile, we compile, sorry, we compile it. We compile it using a compile method in which we have loss optimizer and score. Okay, these three things come in picture in this compiler, and then at the end we fit data set to model. In this we have training data, target of training data, target of training data, epoch we have to define, then we have to define batch size, and if you want you can also define validation data, validation data. Okay, so we are talking we just finished this concept loss. Now I'm talking about optimizers. All right, so let's say I am training a model. This is my model. Okay, I have a data sample, let's say 50 data sample I have. Okay, and I am passing this 50 data sample to this model, and this model is a training first time, first epoch. Okay, first epoch, and it calculate a loss, which is let's say something 90 for now. Just assume it is 90. Okay, on first epoch, on first epoch. Then on second epoch, my model. Let me write it here. My model calculate on second epoch the loss which was 80. Okay, on third epoch my model calculate the neural network calculate loss which is around 60. Okay, that is not fixed like it will go up to with a constant value like 10, 20, 30. No, it may be anything. Okay, so how it is happen? Okay, how my model understand like you have to reduce loss. So there we have something called optimizer, optimizer, optimizer. Okay, now what this optimizer do? So see, we have a neural network where it is a combination of neurons. Okay, so this is a single one. We have logit in this neuron, which is nothing but y is equal to wx plus. Okay, and we have activation part. Okay, so we will not talk about this for now. We will talk about this logic. Okay, so let's say if my model have if my model which is training itself on a data set, and that data set contain two features, x1, x2. Okay, and this is target. Okay, so this model transforms something like this. W1 x1 plus W2 x2 plus B. Okay, so this is we will get. Okay, if we have two samples, if we have one sample, in that case it will look something like this. Okay, so just to show you like why how this got transformed. Okay, according to our feature, I mentioned these two scenarios, but I will talk about this. Let's say my data set have only one feature, not two feature. Okay, in this case, my model will calculate the overall loss of the model, and it will calculate like how far, how far actual value and model predicted value. Now what it is? Let's say I have a data set where we have only two features. Sorry, one feature, x1, and this is time. So in this, I have mentioned a person having 4 years of experience getting salary up to 40,000, okay, or $4,000, okay. A person having 5 years of experience getting salary 5,000. Okay? A person having 6 years of experience getting salary of 7,000. So these are actual values, okay? 40, 4,000, 5,000, and 7,000. But when you will pass this data to this model, it will not show you something like this. It will give you like for first epoch when my model trained first epoch on the whole data set. Okay, like let's say this one. So my model will train on this data, and it will also calculate the actual value and predicted value difference, and it will calculate loss, actual value minus predicted value. Okay, like we were doing in MAE, mean absolute error, or MSE, mean square error. Okay, we calculate actual value minus predicted value, and we get some sort of value on that, which was nothing but loss. We were getting some sort of value, which was nothing but loss. And for single data point, when we calculate loss for a single data point, it is called residual. So let's say my more data set has three samples. If Anyhow, my model calculate this loss, okay, using MAE. So it will calculate a residual of all three data points and calculate the mean, okay, because it is MAE, mean absolute error. So first it will calculate, it will convert all the value into positive, okay, and then it will calculate mean, and that mean is nothing but loss. Okay, so what happened? My model, when it run its first epoch, then it asked internally to my model, okay, like what should be the salary of 4 years? So my model is saying 3,000, okay, which is far away from this point, right? So 1,000 is lossy. Similarly, it is saying uh, how many salary we can offer to 5 year candidate. It is saying, let's say 4,000. Again, it is 1,000 away from the actual point. With 6 year of experience guy, okay, my model is saying we can offer them 5,000, but my actual data is saying no, 7,000 they are offering. Okay, so what are the loss? 2,000. So these are the loss. Now, how my model will understand this? Like we have to reduce the loss because we are getting higher loss, 1,000, 1,000, 2,000. That's too much. Okay? So in that, the optimizer come in picture. Okay, so how it help to reduce the loss? So let me clean the window. Okay, this is, let's say, y, x, and let's say this is z. Okay, or you can also drop like this. Okay, so this is our z. So this is what loss. Okay, this is weight. Weight of what? Y is equal to y is equal to wx plus b. So this is weight, this one, okay, on x. On z, this is nothing but b, okay. So such kind of graph, okay, such kind of graph happened. So what happened? On the very first epoch, let's say this is first epoch, okay. On first epoch, I'm getting loss like 2,000, let's say, okay. So what all parameter playing role in this? Weight and bias. Okay. So we have to calculate derivative. Okay. But why? So on very first epoch, my model is calculating like 2,000 is the loss right now. So my model internally use optimizer and it reduce the loss. Okay. So on second epoch, it is, let's say, saying 1,900 loss right now. On third epoch, it is saying 1,800. On fourth epoch, it is saying, let's say, 1,000. On fifth epoch, it is saying, let's say, 900. On sixth epoch, it is saying, let's say, 800. On seventh epoch, it is saying, let's say, 700. This is the actual minimum loss called global minimum. This is called global minimum, which we generally calculate using uh, optimizer. Optimizer calculate these things using derivative. And in derivative, there is a subdivision called partial derivative. Partial derivative. Now, what is partial derivative? So, partial derivative is nothing. Just to calculate slope, we use. So, So before going to tell you about partial derivative, I would like to focus your attention on derivative, which I have shown you here. Okay. So now let's fully focus on derivative first. Then in second video, I will talk about partial derivative. Okay. So I'm going to clean the window once again. I'm just erasing everything because I am not telling you right now the model working. I'm just talking about derivative. Then I will talk about partial derivative, okay, in the next week. So just to show you this, let's say derivative is looking something like this. Let's say I have a line, okay, I have a graph x, sorry, this is y, okay, this is y, and this is x, okay. There we have, let's say, let me create this once again, okay. Okay, let's say I have a graph, okay. I have two data points. I have two data point A1 and B. A1 and B. If somebody will ask me, Krishna, can you tell me what are the slope? So I will connect them. I will create a 90-degree angle with x-axis. This is x and this is y. And this line I will create parallel to y-axis. It would be 90 degree. So I have to calculate this slope. Okay. So this is represented by theta, the angle I'm representing, but we have to calculate slope. Let's say this is my x-axis and this is my y-axis. Okay, it's this line and this line. So change in y upon change in x. This is very simple, right? To calculate slope. But think about it. What if I will give you one more graph which looks something like this, and there I have a slope something like this, which is a little bit curved in shape. And here I have a point. Now, if I want to ask you what should be the derivative at this point, so you guys will say, how can we calculate derivative of this point? So I would say it is possible, but by the help of derivative kind of stuff. Now, how it is possible? I would say if you will magnify to this one, if you will magnify to this one, you will get you will get a kind of line, okay? You will get some sort of point. If you'll magnify it to a higher level, it will be some sort of value, okay? So this is your delta y and this is your delta x. Now, is it possible to calculate slope? I would say yes. So say slope of this point would be uh, change in delta y upon changing delta x. This is the slope of this point. Now, using further formula, okay, which is already there, we can calculate derivative. Now, I'm not going in depth of derivative, like how to calculate it, but yes, after doing this means after maximizing the length of a curved line, you can find a derivative of each point, okay? So this is all about how derivative work, okay? And this derivative basically use to find optimized value, optimized value, okay? Now, partial derivative, okay? Okay, now if I will show you like how to calculate a derivative of this, so I would say d upon dx, okay? Of let's say this is my f function, so I would say f. So this is my like derivative, how we calculate it, okay? Okay, guys, I'm thinking like I have to create a separate video for partial derivative. It would be great, like if I will create a separate video. So I will create a separate video for partial derivative. But I would like to but I would like you guys to go through this video again and again and try to explore a little bit like how to calculate derivative. No need to do practical stops, okay, like solve mathematical questions. You generally have to get the idea like how derivative work. Okay, that's it. Okay, so that's why I also give you some sort of example here, like how internally my model calculate optimized value. Okay, by the help of derivative, but this derivative is not going to help you much because in our deep learning model, when optimizer work, it calculate partial derivative. And in second video, I will talk about partial derivative. I will let you know how it works. Okay, so for now, just to go through this video, okay, just try to understand, just try to explore. One website is there, math is fun. Okay, this website will help you to understand the mathematical concept like partial derivative very easily. Just go to Google. Okay, just to go to Google, search it here, you will get the partial derivative very first, like you have to click on it. Okay, the website name is math is fun. Okay, so this is all for this video, guys. So guys, this is all for this video. I hope you understand this or you like this. If you really like this, please do like, share, subscribe, share with your friend, families, and let me know in a comment if you guys need any kind of help, you didn't understand it, and we will get back to you in the next video with a partial derivative. Thank you guys. Thank you very much.